Hi everyone, in this video I'm going to be showing you how to perform regression and prediction using stats models in Python. Both my response and feature variables will be numeric. I'm going to also show you how I'm using chatgpt in my project. So let's get started. So I want to show you guys how I'm using chatgpt right now in my project. So for this project, I'm interested in finding out how to run regression and prediction using stats model. So I'm going to ask chatgpt just that. Let's see what it says. So it starts off by telling you the packages that you need to install, NumPy, stats model API, and then it's telling you the ordinary least squares method, OLS, to fit the model, and then you can use a dot summary to print the regression results. And then it goes on to show you how you can predict based on a new set of X variables. And then you can predict based on the new X variable to get your prediction for Y. So that's pretty comprehensive, sort of a general overall summary on how you can do that using stats model. I hope you can try this in your project. So let's go to our Jupyter Lab notebook. So here I'll be using the same one dataset that I've used in my other video projects. So we're gonna start by importing all the relevant packages. And then, so there are two data sets that I'll be using. The first has 150,000 rows of data, and the second one has 130,000 rows. All right, let's start by reading in the first data set, the one that has 150,000 rows, and we'll take a look at it quickly. So it has all these columns: description, country, destination, and we're going to be using the columns points and price in this analysis. Okay, so we can do further exploration on the data. Let's look at the info. And here you can see what are the missing data in each of the columns. And you can also use the describe command and take a look at the mean, standard deviation, and the quantile figures. So next I'm going to be running the scatter matrix. So here it shows every numerical attribute against every other numerical attribute, and you basically visualize the correlation between features, shape of the features through histogram plots. All right, and then next I'm gonna plot a scatter plot between points and price, which are the two numeric variables that I'm interested in. And then I also want to add a trend line to the plot, and I'm gonna limit the y-axis to 1,000 maximum, because you can see there's a lot of outliers right here. So this is how it looks like. So as we can see before, we have some missing values. So here what I want to do is to print out the number of missing values in each column. So here we can see that for our variables of interest, so points doesn't have any NAs, which is great, but price has about 13,000, so that's quite a lot. So what I'm going to do now is to drop NAs in price and points particularly, and I also want to drop those in country and province. So let's run this real quick. And so as we can see, after we dropped NA, both price and points has no more NAs. So next, we're going to be fitting a linear regression model using the OLS function from stats model, and this will be done on the price as a response variable and points as the feature variable. So here I would like to explore how much points can explain the variance in price. So let's run that real quick, and we'll use the fit function as well. And then finally, we'll use the params command in order to look at the parameters. Okay, as we can see here, the intercept is minus 422 and the slope is 5.18. So this means for each additional points, one can expect price to increase by $5.18. So this will be how the equation will look like. So now, with this model in hand, I'd like to utilize this model to predict the prices based on the points in the second wine dataset. So let's start by reading in the second wine dataset. And then I'm going to do the same thing. That is to print out the missing values in wine 2. And as we can see here, there are no missing values in points, but we have missing values in variety, country, province, and price. So what I'm going to do next is to drop NAs in price as well as the 3 other variables here. So let's do that. And as we can see here, both price and points have no more missing values. Let's take a quick look at the data set. It's pretty much the same type of variables as the first data set. Next, I'm gonna create a data frame for the wine 2 dataset, and that's how it looks like. And I'm gonna subset points and price from wine 2 dataset. And let's take a quick look. There you go. We only have 2 variables in there. And I want to quickly look at some quick analysis on the mean, standard deviation. Just a quick look at it. And I'm also going to rename this price variable to original price. So what I'm going to do now is to use the model that we have to predict the price based on the points in the second wine dataset. So let's run this and let's take a look. All right. And what I like to do is to assign the price, the predicted price, into the data frame. Let's run this and now let's have a look. So right here we have the predicted price column that was predicted using our model. Let's also run the describe command to look at some stats. I'm curious to see what the mean is now on the predicted price. So the mean didn't move much, but the minimum did move quite a bit. And also the 25th, 50th, and 75th quantile prices has moved quite a bit. So it's good to look at the stats, but it's also nice to have a plot to visualize the original price and also the predicted price. So we're gonna run this and let's have a look at the plot once it's done. There you go. So we have the original price plotted in green and we have the predicted price in pink. At this point, I would like to evaluate the model performance. There are several metrics that you can use to do that. The first one that I'm interested in is the R-squared. So R-squared represents the proportion of the variance in the response variable that is predictable from the explanatory variable. So we can get the R-squared from the summary command. So let's run that. So here we can see that the R squared is 0.211. So what this means is, looks like only about 22% of variance in price is actually explained by the point variable. And looks like there are other features that are at play. Come to think of it, the result makes a lot of sense. If points is the only driver to wine prices, that means it doesn't matter the country of origin of the wine, the region where the wine comes from, or even the type of grape that's used to produce the wine. The next model performance metric that I'm interested in is called the residual standard error, or RSE. RSE is the measure of the typical size of the residuals, how much the predictions are typically wrong. So you can calculate RSE by a couple of ways. The first is to use the MSE_resid command, and then you take the square root of that. So let's run that real quick. So we get an RSE of 32.25. This means the difference between the predicted value of price and actual price is typically about 32.25. So the model has an average error for price of around $32 per point. So I'm going to show you an alternate way of calculating RSE manually. So for each observation, we'll be calculating the vertical distance between the observed value and the predicted value. So we take the difference between predicted price and original price, and we square it, and then we calculate the number of degrees of freedom. And then what we do is we sum that residual square, divide that with the degrees of freedom, and then we square root that. So let's run the cells quickly. So as you can see here, the manually calculated value is 37.3, which is pretty close to the one that we got before. So we've come to the end of our session today. I hope you enjoyed, and I strongly recommend that you try it out yourself. I'm going to put a link below to my GitHub account so you can download this Jupyter Lab notebook and also the data set that you need for the analysis. If you like this video, please give me a thumbs up, and if you haven't already subscribed to my channel, please do so by clicking on the subscribe button below. Until next time, bye!